Okay, guys, we're going to start talking about compound probability at this point. Compound probability is when more than one thing happens. So we were talking about simple probability in the last video. Compound probability specifically says up here at the top that it's two or more events put together to make one event. Sometimes it's the union of those events. Sometimes it's the intersection. Where do they come together? And at the very beginning, it says you will see the word or. Or means to blank probabilities together. What we're going to do anytime we see an or is we're going to add probabilities together. There are also different types of those compound events. Some of them are disjoint, meaning that one's going to happen or the other's going to happen, but they're not going to happen at the same time. And some of those are overlapping. One can happen, another can happen, and they could happen at the same time. So for example, if it's disjoint, and this will affect how we actually do things, how we calculate the math. If we're talking about a deck of cards, choosing a 3 or choosing a face card. A face card is like a jack, a queen, or a king. And so a 3 is never a jack, a queen, or a king. How many 3s are in the deck? 4. How many face cards are in the deck? There are 3 different kinds, 4 different suits, so that makes 12 of those. But you're never going to have a 3 and a face card on one card. Now, if we talk about overlapping events, we have to do some special calculations. What if we chose a black or chose a 3? Well, you could be a black card and you could be a 3 card as well. So those could overlap, and I'll show you how to do the math for that. So if we go to example 1, it says there are 7 red, 8 green, and 6 blue marbles in a bag. Kate is going to select one marble at random. What is the probability that she will select a green or a blue marble? And so what we're going to do, and we did this actually on one of the basic probability problems on your last notes, is we're just going to add those together. Anytime we have the word or, we know we're going to add. So how many green marbles are there? There are 8. How many blue marbles are there? There's 6. And so I just add my 8 plus 6, and that gives me 14. But out of the whole bag, I have that 14 plus 7. 14 plus 7 gives me 21. So this is 14 out of 21. Now, I can reduce this. So to reduce, all I would do is just go ahead and divide by 7. And that gives me a 2 out of 3 chance. We have a 2 out of 3 chance. Sorry, taking my time there. All right, on number 2, a card is randomly selected from a deck of 52 cards. What is the probability that the card is a 10 or a face card? If you don't know anything about cards, these kind of problems stink. Unfortunately, this seems to be what probability problems focus on a lot. You do need to know there are 52 cards in a deck, unless we're adding jokers in, which they will be specific and tell you if they are. And there are 4 different kinds of cards. You've got your diamonds, you've got your hearts, you've got your clubs, and you got your, I'm forgetting what the other one is, diamonds, hearts, clubs, and spades, I believe. But anyway, there's 4 different kinds. 2 different kinds of red suits, 2 different kinds of black suits. So when we talk about how many 10s there are, then we would have 4 different kinds of 10s, 4 in each of those suits, or 1 10 in each suit. When we talk about face cards, we would have a jack, a queen, and a king in each of those 4 suits. So we'd have one of those in each of those 4 suits. That would be 12 cards total. So we know we have 4 10s, or means add, 12 jacks, queens, or kings out of all the suits, out of a total of 52 cards. And if we add those together, we would have 16 cards out of 52, and then we would reduce. So I'm just going to go to Desmos, and you can reduce by hand if you want to. But remember, you can just type in 16 over 52 and let the calculator do it for you. So that gives you 4 out of 13. So again, theoretically, every time you draw 13 cards, 4 of those will either be a 10 or a face card. All right, our next problem. It says you roll a fair die. That means we have 6 sides. What's the probability that you roll a 1 or an even number? Well, how many 1s are there on a die? So remember the numbers on a die, and that's what you call it if there's just 1. If there's 2, you call it dice. But anyway, how many 1s are there? There's 1. How many even numbers are there? 1, 2, 3 of those. If I add those numbers together, that gives me 4 total numbers that I'm working with out of 6. And then I can reduce, and I get 2 out of 3. All right, so let's look at one more problem in this section. On number 4, it says, in Mrs. Carr's math class, 9 of the 14 girls say they like math, and 7 of the 16 boys say they like math. If Mrs. Carr randomly selects a student, what is the probability that she chooses a girl or someone who likes math? Now, this is actually getting into probability that overlaps. So we're going to talk about the whole class altogether. Out of the whole class altogether, how many students are girls? Well, if we go back and look, there are 14 girls in the class. Plus, how many students like math? Because it does say or, so we're going to add. So we know 9 girls like math and 7 boys like math. So 9 plus 7 would give us how many people like math. But here's the problem. There's an overlap. So if I go back and I look, I know that I've already counted the girls when I counted the total, but then I counted 9 more of those. So how much of that is an overlap? There would be 9 girls that overlapped out of that total. So because I counted them for the 14 girls and I counted them for how many like math. So what I would have to do at this point is subtract those girls out. Those girls that I've counted twice. At this point, I would count, okay, what is the total amount? And if I add, I have 14 girls and 16 boys, so that would be 30 altogether. And basically, these 9s are going to cancel. I'm only going to add those together. 14 plus 7 gives me 21 out of 30. And if I reduce that by dividing by 3, or again, you can do that on the calculator, you get 7 over 10. And so anytime you have some kind of overlapping possibility, you do have to subtract that out. So let's look at another example, which would be number 6. Sorry about my phone ringing here. All right, on number 6, it says you roll a fair die. What is the probability that you roll a 4? So how many 4s are there on a die? There's 1 4. How many even numbers are there on a die? Well, the numbers 2, 4, and 6 are even. So anytime I have the word or here, I'm going to add that in. That means I have 3 more numbers than I'm looking at. But do I have any numbers that are 4 and even? Well, 4 is an even number, and there's one of those on a die. So I've got to subtract that 1 out. There was a total of 6 numbers altogether, and so basically my 1's cancel. Or I could do 1 plus 3 is 4, and 4 minus 1 is 3. Don't forget to reduce your fraction, and that's going to give you 1 out of 2. The compound is a little bit harder, especially when it overlaps, so it is different. All right, so let's go back and let's look at something, or let's go to the next page and let's look at something that's a little bit different. We're going to talk about things with replacement and without replacement, meaning if we take something out, we pull a marble out of a bag, are we replacing it for the next go around, or are we leaving it out? Because that's going to reduce the amount of marbles that you have in the bag. And so that's going to affect how you solve a problem. Let's look at number 1. It says, out of a class of 20 students, your teacher chooses students at random to present their project. What is the probability she chooses you first and then chooses Kim second? Well, how many of you are there in a class? There's 1 of you out of 20 total students. At that point, we're going to choose Kim. And if we're choosing Kim, and one thing I didn't point out, and I'm sorry, doing a video is not ideal, anytime it says the word and, we're multiplying. It reduces our chances greatly if you want something to happen and something else to happen. And so I'm going to put multiplication in between my fractions at this point. And then we're choosing Kim. So how many Kims are in the class? There's 1 Kim, but you've already been chosen. And so at this point, she's not going to choose you again. She's choosing from 19 students. And so if we multiply that together, we get 1 times 1 on the top, 20 times 19 on the bottom. And I've already done the math for this. I kind of cheated ahead of time. So there's a 1 in 380 chance that she chooses you first for your project and then Kim. And so when we start talking about things that have to happen one after the other, one and the other, our probabilities greatly reduce. And so what's the probability of you winning first place in something and your best friend winning second place out of a group of 100 people? Well, that probability is going to be pretty small. All right, let's look at number 2. You flip a fair coin. So think about a coin. On a coin, there's a heads and a tails. What is the probability that it shows heads on the first flip? Well, there's one head out of two sides. And then I see the word and. When we see the word and, remember we're multiplying. It shows tails on the second flip. Well, the coin's still the coin. I can't take off the heads. I'm going to flip it again. So I still have two different sides to the coin, but there's only one tails. And so if I multiply straight across, because it said and, 1 times 1 is 1, 2 times 2 is 4. There's a 1 out of 4 probability. All right, so let's look at number 3. And then you're going to have, and then we'll look at actually another 1 or 2, and then you'll have some time to do some work. Tom has 4 navy socks and 6 black socks in a drawer. One dark morning, and I've been there and done this, he randomly pulls out 2 socks. So if you're pulling out 2 socks to wear, you're not putting one back in the drawer. What's the probability that he will select a pair of navy socks? Okay, the first go around, if he pulls 1 sock out, how many navy socks do we have? We have 4 navy socks out of a total of how many socks? 4 plus 6 gives us 10. The second go around, we have to select another sock. So this is an and problem. I want this sock and another navy sock. Then I've already taken out a navy sock. I didn't put a sock back in the drawer. So I have reduced my number of socks overall to 9, but now I only have 3 navy socks in the drawer, assuming I pulled one out already. And so not only did the bottom number reduce, the top number reduce as well. So this can get really confusing. So across the top, I get 12 when I multiply. Across the bottom, I get 90. And I'm going to go ahead and reduce those. And let's see. Divide by 3, divide by 3. That's going to give me 4 over 30. I should have just used the calculator. I'm going to divide by 2, and I get 2 out of 15. So I guess I should have divided by 6 to begin with. So you really got to think this math through. Compound is a little bit harder. Remember, the word or in a problem means we're adding. The word and means we're multiplying. Okay, let's look at, let's see, number 5. On number 5, it says that Steve reaches into a bag with 5 red, 3 yellow, and 2 green marbles and randomly selects one. Then he puts the marble back. That's important. And he reaches back into the bag and selects another. What's the probability that both guys, or this is another guy, selects a yellow marble? Well, how many yellow marbles do we have? We have 3 out of a total of 5 plus 3 plus 2, which is 10. So when Steve reaches in, he has a probability of 3 yellow marbles out of 10. That's his probability of pulling one out. And then it says the word and. So if it says and, we multiply. Sam reaches into the same bag and selects a marble, and we put that marble back in. So again, there's still 3 yellow marbles out of a total of 10. If I multiply straight across, I get 9 over 100, and I can't reduce that fraction. That means out of 100 attempts of doing this, Sam would pull a yellow marble, and then, or Steve would, and then Sam would. 9 out of 100 times. All right, so let's look at this last page here, and let's look at number 9. A box contains 5 red and 7 green marbles. Find the probability of drawing 2 red marbles with replacement. So I'm putting it back in the first go around. There are 5 red out of a total of 12 marbles. And if I put it back in and I do it again because I want to draw 2 red, there's again 5 out of 12 marbles. And so if I multiply across, that gives me 25 out of 144, and I can't reduce that. Now, it's a little bit different when I say without replacement. There's still in the very beginning 5 out of 12 marbles total that are red. If I'm going to not replace that marble, then I'm going to assume at this point I have 11 marbles in the bag, and now only 4 are red, because not only did I pull a red out, I also didn't put it back in. So now I only have 4, and there's 11 marbles in the bag. So if I multiply straight across here, and I'm just going to reduce beforehand, you can do this on the calculator, but I'm going to divide that by 4. I get 1. 12 divided by 4 is 3. And so now if I multiply straight across, I get 5 over 33. And so those are 2 totally different fractions, whether you replace or you don't. I know this work will be a little bit more difficult for you because I'm not there with you, but I still want you to try it. Remember, you always have 2 attempts, and if you'll go through it and answer the first time, if we need to go over it tomorrow, we will, or on Monday.